Hello, welcome to Chapter 4, Homework Questions 116 to 121. Question 116. Avery has been learning to play some new card games and is curious about the probabilities of being dealt different cards from a standard 52-card deck. Help him figure out the probabilities listed below. So on Part A, we start with the probability of a king. There are 4 kings in a deck out of 52, so that would be 4 out of 52. Then we have the probability of getting a queen, and it's the same thing. There are 4 queens in a deck, so 4 out of 52. And then the probability of a club, there's 4 suits, 13 in each, so 13 out of 52. On Part B, what is the probability of getting a king or a club? So the probability of getting a king is 4 out of 52. And the probability of getting a club is 13 out of 52. So if we take the intersection or the OR on this one, we'll do 4 out of 52 plus 13 out of 52, but then we have to subtract the overlap, and there's 1 king of clubs, so that would be 1 out of 52, and so 17 minus 1 would be 16. So the probability of getting a king or a club would be 16 out of 52. And then it does say, how does the answer relate to the probabilities you calculated in Part A? Well, we use the probability of a king and the probability of a club to help us figure that out. We have Part C now. What is the probability of a king or a queen? So we got king or queen. We have 4 out of 52 kings. We also have 4 out of 52 queens. And since there's no overlap with king and queens, we have 8 out of 52 as our probability. And again, how does the answer relate to the values calculated in A? We use probability of king and queen, and we're able to add them up. Once again, no overlap on that one. Part D, what is the probability of not getting a face card? There are jacks, queens, and kings in each suit, so we can find the probability of jacks, kings, and queens. We'll just do all of them. Jacks, queens, and kings. 4 different suits, 3 in a suit, so that means there's 12 out of 52, and so to not get 1, we'll do 1 minus 12 out of 52, and that would be equal to 40 out of 52. And so once again, you can reduce that if you want to, but it's okay for now to leave it as 40 out of 52. Question 117. Woottonville currently has a population of 1,532 people and is growing at a rate of approximately 15 people per year. Nearby, Cornertown has a population of 2,740 people, but is decreasing at a rate of approximately 32 people per year. In how many years will the towns have the same population? So let's define some of our variables. We'll let t equal the time in years, and then we can let p represent the population. So right now, currently for Woottonville, the population is equal to 15 people per year, so 15 times t plus where they're currently starting at, which is 1,532 people. And at Cornertown, the population is equal to 32 people per year, but it's decreasing, so negative 32 t. And the population is starting at 2,740. So now we want to know in how many years will the towns have the same population. We can go ahead and solve this as a system since we're looking for the population as to when they will be the same. we add 32 to 15, or add 32t. That is 47t. And then we will subtract 1,532. And then divide by 47. And we get approximately 25.7. So to answer the question, in how many years will the towns have the same population? In approximately 26 years. Question 118. Examine the diagram below. If line segment AC passes through B, then answer the questions below. Part A, are the triangles similar? If so, make a flow chart justifying your answer. So right now we know angle A and angle E are congruent. We also know angle B is a right angle, and since it says segment AC passes through point B, since that's a line, that also represents that this is a right angle. So by angle similarity, we know that the triangles are similar. So now we need to make a flow chart to justify our answer. So we can say that the measure of angle A is equal to the measure of angle E. We can also say that the measure of angle, now B has a couple angles, so we got to measure it with 3 letters. We'll say A, B, we can use D or E. I'll use D since it's part of that triangle. Measure of angle ABD is equal to the measure of angle EBC. And it's important that you use 3 letters on that angle B because of, once again, there's an angle here and an angle here. So you have 2 different ones and you have to use 3 letters for that. And then we can say because of that, we know that triangle will go A, B, D is similar to triangle. A matches up with E. B is going to match up with B. And then D will match up with C. So we know those are similar by angle similarities, and don't forget the arrows. Part B wants to know if the triangles are congruent. Explain how we know. Well, right now, on this triangle, we only have one side length, which is BC, and that is 9. And for that to be congruent, BC would have to match up to BD. Well, BD we don't have, but we can find it because it's a right triangle. We can use Pythagorean theorem. So 12 squared plus, let's call this x squared equals 15 squared. So we have 144 plus x squared equals 225. Subtract 144 from 225, we get 81. And x is equal to 9. So since BD and BC, which are corresponding sides, are equal, then yes, they are congruent. Once again, because we found that side length, which means also, we could write it this way, that the common ratio is 1. That's another reason why they would be congruent. Question 119, examine pentagon SMILE at the right. Do any of its sides have equal length? How do you know? Be sure to provide convincing evidence. You may want to copy the figure onto graph paper. So we could kind of look at our slope triangles here from each of these. So S to E, you can see that it is up 1 and over 3. And so that side length would be 1 squared plus 3 squared equals that. So if we have any others like that, and we do right down here, this would be 1 and 3. Even though in terms of the slopes themselves are positive and negative, that length would still be the same. So SE and MI would be of equal length. And then also it looks like, even though this one's going the other way, this is still 3 and 1, so therefore that hypotenuse of the triangles will all represent the same length. So we know the measure of SE is equal to the measure of MI, is equal to the measure of Li. And are there any others? Let's see, this one over here would be a 3-2 triangle, and then this one right here is also 3-2. So we know that SM would be equal to EL. So do any of the sides have equal length? We've said that. How do we know? Talked about the slope triangles, using those. As long as they have the same side lengths, then the hypotenuse would be the same. Be sure to provide that convincing evidence on your paper as well. Question 120. Find the area of the triangle below. Show all of your work. So we got a right triangle. To find the area, we need to have the height and the base. And so you can see with the right angle, this would represent the height or the base. It doesn't matter, but we need both of them. And right now we only have one, so it looks like we will have to use the tangent ratio of 34 degrees. That would be h over 17. Could multiply both sides by 17. So whatever 17 times tangent of 34 degrees is, that would represent the, whoops, I messed up, the height of that triangle, and then we can find the area. So h is approximately 11.47 millimeters. And then we can use that to find the area. So the area is 1/2 times 17 times 11.47. And so we'll get an area approximately equal to 97.47 millimeters squared. And just to clarify something real quick, this answer is if you use exactly tangent of 34 degrees times 17. So instead of plugging in 11.47, you plug in that exact answer. Otherwise, the area will be approximately, based on what we have here, would be, maybe that's confusing, but would be approximately 97.50 millimeters squared. So it just all depends on how you're rounding your answer. Question 121. On graph paper, plot triangle ABC. Alright, I've done that. Part A, enlarge or dilate triangle ABC from the origin so that the ratio of the side lengths is 3. Name this new triangle, triangle A prime, B prime, C prime, and list the coordinates of those. So from the origin, if we're 1 unit over and 1 unit down, we'll just do that 3 times to get 3 times that ratio. So that would be 1, 2, 3. So there's where A prime would be. So A prime is located at -3, 3. C is 1 over 2 down, so we'll do that 3 times. That would be here, here, and here. So this would be C prime, and C prime is located at -3, -6. And then for B prime from the origin, it's 3 to the right, 1 down, or 1 down and 3 to the right, either way you want to do that. Do that 3 times. Here and here would be B prime, and that looks to be located at 9, -3. Alright, on B, we're going to rotate the new triangle 90 degrees clockwise about the origin to find A double prime, B double prime, and C double prime, and once again we will list the coordinates. So I'll do that down here. So I went ahead and rotated it clockwise. Tracing paper would be good for this as well, and so you can see what the new coordinates are and the new triangle. Part C, if triangle ABC is translated so that the image of A is located at 5, 3, where would the image of B lie? So I've located the point 5,3, and that would be your new A. So how would you translate? You'd go up 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6. So you'd go up 4 and over 6. So if we did that with B, we would go up 4 and over 6. 1, 2, 3, 4, 5, 6. And that would be at the point 9, comma 3. So B would lie at 9, comma 3.